After we talk about the ER and EER model, it is time for us to look into the relational model concepts to learn how do we design a relational schema diagram, which really serves as a pseudocode for you to do the programming in database. So let us take a look of the relational model concepts. It is very similar to the ER and EER model, however, there are some differences. A relation is a mathematical concept based on the idea of the sets. As you know, many computer science stuff derived from mathematics. In 1970, which is 50 years ago, and you need to understand, compare with math, chemistry, physics, 50 years is like an infant. So the model was first proposed by Dr. E.F. Codd of IBM Research for the following paper. And this paper is called A Relational Model for Large Shared Data Banks, which forms as the foundation for all the database that we learned today. This paper also earned Dr. Codd the coveted ACM Turing Award, which is like the Oscar in computer science area. That is the highest honor in a computer science world. So based on his paper, these are the concepts that we need to understand in order to design what we call the relational schema diagram. So here's the outline. Relational model concepts, which will start talking about the domain, attributes, and relations. And after that, we will look into the characteristics of the relations. Once we have looked into those things, we will look into the schemas, which is the place that we learn how to draw the relational schema diagram. And then we will look into how do we do the data that been stored inside of the structures that we have been built up. So this chapter is very important for us to really do the implementations about the database. So starting with the domain, attributes, and relations. Relational model concepts. The relational model represents the database as a collection of the relations. And this relation is like the table that we're looking into. Each relation is a table. So student relation is a student table. Employee relation is an employee table. Department relation is a department table. So those are the things that we want to look into. When a relation is thought as a table of the values, each row inside of the table represents a collection of related data that we are interested in. And therefore, if we looked into this table, you will understand each row is called a tuple. So in this student relation, also student table has 5 tuples, indicating there are 5 students. Each column is represented as an attribute. So in this table or in this relation, it has 1, 2, 3, 4, 5, 6, and 7 attributes. Domain. For each attribute, we want to define the domain of it. So a domain D is what we call a set of atomic values. What is the meaning of atomic? Atomic means that each value in the domain is indivisible as far as the relational model is concerned. And therefore, when you comes to this part, you will understand atomic value indicating those simple and single attributes. When it comes to composite attribute, that is not an atomic value. When we talk about the multi-value attribute, that is not an atomic value. And therefore, we need to handle those things especially. So again, atomic value means that if we separate atomic value, then the value itself becomes meaningless. For example, social security number. It's impossible that you take only part of the social security number and make the sense out of it. Local phone number without the area code, names, employee ages. So those are the things that what we call atomic value. And therefore, for relational database, we want to store atomic values. A relation schema R denoted by R composed of multiple attributes. So if this is a student table that we were looking at, then we call it a student relation. In our example, we have 7 attributes, so you will have A1, A2 until A7 is made up of a relation name and a list of attributes. Each attribute, so every single attribute that we're looking at is a name of the role played by some domain D in the relation schema R. What that's trying to say is that inside of the relation, there are multiple attributes. So for every single attribute that we are looking at, there is a domain that we want to define. What is a domain? A domain means the possible values that you can store in that attribute. D is called the domain of AI, is denoted by what the domain of AI. So that's how we're going to present what is the domain of each attribute going to be. So R again is called the relation. The degree of the relation is the number of attributes. So basically in the student example again, the student relation has 7 attributes. So the degree for the student table is 7. Now let's look into the domain definition. So given R equals to described by multiple attributes, and each attribute has a domain. So what we are going to present, the whole relation is equal to the domain cross product with another domain A2 until all the domains in the end of it. So R of A1 until AN is called a schema of the relation. Basically, it's how we design a relation. R is the name of the relation. A1 through AN are the attributes. So let's take a look at the example to understand it. Say now we create a relation R. It has 2 attributes. 2 attributes are pretty straightforward. The first attribute has only 2 possible values. So domain of A1 equals to 0 and 1. Domain of A2, there are 3 possible choices over there. And therefore you understand when R is defined by 2 attributes, and we also define each attribute of the domain, we define the domain of each attribute. By looking into that, you will understand for this relation, there are only 6 possible combinations, because 0 can pair up with A, B, and C, 1 can pair up with A, B, and C, so you end up with only 6 different values that you will be able to store. And therefore you understand that to define each domain is very important in the relation definition. It's going to be the same thing when we are going to write a program. Because when we are writing a program, we will need to define the name of the relation. We need to define each attribute. While we define each attribute, not only we need to provide the name, but also the data type and the space out of it, so that we will be able to define the whole relation. So here is a summary of what we have looked into. There are some formal terminologies that we use. There's also some informal terminologies that we use. So that for the relation, it's like a table. A column header is attributes that we are looking at. All possible column values is defined as the domain. Each row is representing a tuple. The table definition is what we call a schema of the relation. Once we define the whole table, we will be able to start populate the table that will indicating a different state of the relation. So that is the basic terminologies that we want to use in the relational model. So now let's take a look at some special characteristics. The first characteristic that we want to look into is the order problem. Order does not matter in database. What does that mean? Let's take a look at this. A relation is defined as a set of tuples. Mathematically, elements of a set inside the set theory has no order among those. The ordering indicating the first tuple, second tuple, 10th tuple, etc. Hence, the following 2 relations are considered as identical. Let's take a look at this example. So you can see that we have a student table. There are 5 students over there. the values are all the same. So you need to understand the only difference is that in here we have Benjamin listed as the first student, while we have Dick listed as the first student over here. The order is different from the two tables. However, we consider two tables are exactly the same since order does not matter in database. It should be pretty straightforward and understandable. Now, each values in the tuple. Each value in the tuple has to be atomic value. Hence, composite and multi-value attributes are not allowed. When we see those things, we will need to make some modification. Composite is pretty straightforward because a composite attribute indicating that attribute is composed of another several attributes. So what we need to do is list those more detailed attributes to describe the composite attribute. So this is not going to be a difficult thing. For example, name can be a composite attribute of first name, middle name, and last name. So what we want to do is simply include first name, middle name, and last name, because those three things combined together equals to name. Then we will use those three atomic values. For a multi-value attribute, it's a little bit more complicated. So what we need to do is basically need to create an array for multi-value attribute, and which means create a new table to hold those values. When we comes to the conversion of the ER model to relational schema diagram, we will have very detailed step-by-step operations to describe how do we do those operations. So, since all the values that we want to store has to be atomic value, this model is sometimes called the first relational model, or what we call the first normal form. Those things are like the basic requirements. There's going to be some more strict operations called like second normal form or even higher, but first normal form is the one that force us to store all the values in atomic value. And again, that's only because computer holds one value for each variable. And this is the easiest way of handling things for computers. Null value is in the same concept of the ER diagram. An important concept that if null value is there, which is used to represent the value of attributes that may be unknown or not applicable. So that, for example, a person, employee's college degree, if it's null value, maybe it's because he does not have one. Or maybe we just don't know what is that employee's college degree, since there's no star sign on top of it to require the values has to be there. So that there are two possibilities of a null value. And therefore, when we try to specify which attributes that we are interested in, we are not going to say the third column of the student table. We don't do that. We use the ideas of the object-oriented concept, saying that, okay, the name of the student attribute is what we are looking at. So what we are going to do is that we try to provide the table name first or relation name first, dot attribute name. This way is very clear. And then even if you have like duplications of the name, for example, student has a name attribute, faculty has a name attribute. While we are specifying this way, student.name or faculty.name will be able to distinguish one from another. So you can have same name in different tables. And that's how we'll be able to specify the information. So that is the basic concepts of the relational model. In our next video, we want to look a little bit deeper into the ideas of the key, the ideas of the foreign keys, and how do we design or draw a relational schema diagram.